The law of conservation of energy, or the first law of thermodynamics, states that energy is neither created nor destroyed during any physical or chemical reaction. This is similar to the law of conservation of mass, which states that mass is not created nor destroyed during a physical or chemical reaction. Both matter and energy change forms during these reactions, but neither are destroyed or created. Matter transforms during chemical and physical reactions, and so does energy. Heat is another classification of energy that doesn't fit neatly into the categories of kinetic and potential energy, but it is related more to kinetic energy. This gives a clue as to how tricky it can be to define energy. For our purposes, we are just going to scratch the surface, and we will think about heat as a form of energy that flows from high temperature to low temperature through the motion or kinetic energy of particles of matter. When atoms, ions, or molecules absorb heat, they move more. Most chemical reactions release heat, which is transformed potential or chemical energy. So heat is a useful concept for chemists. We have already addressed heat in this class, but it's useful to reconsider some of these concepts. There's no absolute zero of heat, so we always measure heat by difference, or the change in heat. It's helpful to remember that although heat and temperature are related, they are not the same thing. There is an absolute zero of temperature, 0 Kelvin, but not of heat. Heat is a type of energy and can be expressed in units of joules, capital J, kilojoules, lowercase k, capital J, calories, or CAL with lowercase letters, calories with capital C, which is equal to kilocalorie, KCAL, all in lowercase letters. Temperature, on the other hand, has units of degrees Fahrenheit, or degrees symbol capital F, degrees Celsius, degree symbol capital C, and Kelvin, or capital K.